So this is Learning Target 7, and there's not going to be a sheet for that. So this is kind of going to be my way of introducing it. So at the top of this, you can go ahead and kind of use this as your notes. This is going to be Unit 3, Learning Target number 7. And the learning target for that is I can analyze a graph and find its rate of change. So we already know how to find rate of change from a table, right? Okay, so we know how to find it from the table. We're just going to analyze a graph now and find the rate of change from the graph. So, and this is the way that I like to introduce this every year. I just kind of like to put it out there and kind of walk around and listen to some of the things I'm hearing. I heard some really good things. I heard you can't go backwards in time. It can't be that one, which is great. I also heard, well, those are the stairs, the steps of a stairs. He needs to just walk up those steps, and that's what steps look like. So we're going to kind of debunk some misconceptions. You know what that means? So if this is time, this is your x-axis, and this is speed. Now be careful, because when it's distance, it's a little bit different. So speed means this is a straight horizontal line, which means the train is going what? At a steady speed. So here's what I want you to think about. Put numbers to the axes to help them make sense to you. So if this is miles per hour, let's say this is 10, 20, 30, 40, this is 80 miles an hour. As every minute goes by, this train is traveling 80 miles. So they're going 80 miles an hour, 80 miles an hour, 80 miles an hour, and then they just stop. Like, I don't know about you, but you ever seen a train? They're huge, they're heavy, they take a long time to slow down, right? So it cannot just stop. So it's not those. This would be the engineer kind of messing with people. He's going faster, then slowing back down, and going faster and slowing back down. So by default, it has to be this one. Because as time is continuing to increase, his speed is what? Decreasing. So B. Raise your hand if you had B. Good. Lots of hands. Okay. A man is taking a ride on a Ferris wheel. So let's talk about what JC said. So here's time. 1 second, 2 seconds, 3 seconds, 4 seconds into the ride, 5 seconds. Oh, back to 4 seconds, back to 3 seconds, back to 1 second. I know we wish we could turn back time sometimes, like Cher says. You guys even know that joke, Cher? Okay, never mind. Just look it up. So if you wish, you could do that, but you can't. So you can't go backwards in time. So it's not A and it's not D, right? So now let's think about the shape of a Ferris wheel. The shape of a Ferris wheel is circular. So you're loading. This is why it's starting here, because you're standing on the ground, and usually you have to get up on a platform, right? And then you are as high as it goes, and then it gets back down, but never back to the ground because you're still in the cart, right? And then you go back up and you come back down. Okay? So this one is B. This would mean, like when you're on a Ferris wheel, this would maybe mean like the shape of the Ferris wheel was like an oval instead of like sometimes you're that high up. So these are all different heights, but aren't you the highest height up? And when you're at the highest height, aren't you at that same height every single time you're at the top? So that one is B. Raise your hand. Anybody? Okay, and I need honesty too. We're going to go 5 for 5. So you are 5 for 5ers. Okay, this one is probably the most the ones that people have the biggest misconception on. The shape of the graph does not match necessarily the shape of the path that the person is going. So it's not B right off the bat. Okay, let's talk about this. A steady pace. Well, if this is 1 mile an hour, 2 mile an hour, 3 miles an hour, 4 miles an hour, as time is increasing, I want you to circle the word steady. Steady means you're driving in your car and you have cruise control on, okay? So as the seconds are going by, this person is still traveling at 4 miles an hour, which is about a walking speed. Does that make sense? So 4 miles an hour, it doesn't change. Then, what would happen here? I don't know about you, but what happens when you run down a hill? One of my best memories ever was my niece at my grandma's house. She has a big hill in front of her front yard, and she was 2. And just, it's so horrible to laugh about it. But we were all like, we couldn't do anything because she was going so fast. It was like a cartoon. Like her legs were like in a wheel, and she did not fall. We were like, holy cow, that was going to be. So when you run down the side of a hill, you ever do that? Where for a split second, you're like, oh my gosh, my legs are not going to keep up with me because this hill was a little too steep. Do you ever think about that? Then you like for a minute. Anybody ever done that and actually bit it? Sorry. I don't know why I find it funny when people fall and stuff. As long as they're okay, but I don't know. Yes. Oh, it's horrible. But it was one of the. She's 21 years old now, and it's still like one of my best memories ever. So, what's actually happening during this right here? Her speed is increasing, which is what happens when you run down a hill. This does not mean she's going up the hill. So this is kind of weird. We didn't expect this one, did we? So this graph would mean, first of all, I'm not at a steady speed. As the time is increasing, my speed is increasing. So I'm going 1 mile an hour. Then I'm going 2, 3, 4. And then when I get to the top of the hill and I run down, my speed decreases. Right? That doesn't make sense. It's kind of backwards. So I know you probably thought it was B, but it's not. This would mean you're climbing up the hill and your speed continues to increase. And I mean, I guess this wouldn't be too crazy to when you're running down the hill that you stay at a steady speed. I mean, I kind of think by nature you speed up without trying to, but so it's A. Okay? Anybody 3 for 3 now? Anybody, did that throw anybody off? Isaiah, Audrey, AJ? Okay. A child is swinging on a swing. I'm just going to tell you right now, it's not the path that the swing takes. You have to stop and think about what the axes mean. All right? So they're here. They're sitting on a swing. And when you start to swing and you kick back, you go a little high off the ground, right? And then that's this. And then you get what? Back. Well, before you get higher, you get lower. So your distance gets right back to where you started. Then if you pump your legs and you go kick hard enough, then you get a little higher on the next one. Then your distance to the ground goes back down because it always has to go back down, right? So the answer is A. Okay, did we have A? Good. All right. It is not B. Just because he's walking up steps does not mean that it looks like steps. All right? This would mean that they stand still and then they go at a steady space. Then they stand still and they walk up the stairs and pause every time. So let's take a look at this one. The time, so the speed is increasing, and then what happens right here? Stays the same and then slides down. So the speed is not decreased when you go down a slide. So let's take a look at this one. When you are climbing up a slide at a steady speed, this means you're climbing up the steps, right? And when you climb up the steps, isn't it pretty steady? You just kind of walk. So there's your steady speed. Okay, so what I want you to know for Learning Target 7 is this. I'm going to break graphs down into segments. So I'm going to say, segment A, tell me what's going on. Segment B, what's this kid doing? Right at C, what are they doing? At D, what are they doing? And at E. So you need to be responsible for being able to explain what's happening. So A, steady speed, they're climbing up the steps. B means what? What's happening? Their speed is slowing, they're stopping, and what is happening at C? What do you usually do before you slide down a slide, unless you're nuts? You sit down, right? So their speed is what right here? 0. They're not moving. They're sitting down. And then what happens here? Woo! Their speed really increases because they're going down an incline, and then their speed stops when you get to the bottom. Does that make sense? So did you hear what I just explained this? Climbing at a steady rate, their speed is slowing down because they're sitting down, they're totally still, they just went down the slide, and then their speed is coming and slowing down, and now they're done. Okay? So this is C. Anybody? 5 for 5? Oh, that one got Isaiah. Okay, did we have this one? For D? Anybody? Yeah? Okay. Okay, so that's an introduction to what we're doing. The next thing I want you to take a look at is if you had some papers on the front of your desk, if you did not pass them back yet, go ahead and do that. So let's take a look at this choo-choo train speed. And now we have graphs with numbers on them. And this is where part 2 of Learning Target 7 comes in. Because now in addition to explaining what's going on, you need to give me the rate of change. All right? So I might say, like it looks like from here to here, that's a constant rate of change. We're going to call that A. We're going to call this stretch from here to here B. And then we'll call this stretch from here to here C. So 2 things out of today that I need from you. What's going on? Tell me the course that this path is, that this choo-choo train is taking. It's speeding up at a steady rate right here. Or not, I'm sorry, not a steady rate. Its speed is increasing, continues to increase. And what happens eventually when you're driving? Eventually you reach the speed that you desire, and then you stay at that speed, right? Until you got to slow down for a red light or make a turn or whatever. So here's what I need you to understand. So if you have a highlighter, or just circle it. When our axis is speed, a horizontal line means what? Let's just take a little closer look. At 12 seconds, how fast is this train going? 24 meters per second, miles per second. At 14 seconds, how fast is the train going? The same. At 15 seconds, how fast is the train going? The same. Does this mean that they're standing still and they're stopped? No, their speed is 24 miles per second. Meters per second, more likely. So, when you have a horizontal line on a speed versus time, this means you got the cruise control set. Okay? It's going to mean something totally different when this is distance. So I need you to kind of just really stop and think about it. The word analyze in our learning target is so important here because that's exactly what you're doing. Okay? So that's part 1. The train is speeding up. I might say, how long does it take them to speed up and reach the speed that they want? How long does it take them to get to that speed? 12 seconds, right? I might say, what's happening from 0 to 12 seconds? You would say the train is gaining speed, right? Got it? Okay? So, now, I may say, what is the rate of change from 0 to 4 seconds? And you need to be able to give that to me. So this is new. So please watch. So if you do have highlighters or different colors, it might be a little helpful. So we know that the rate of change is the change in your y value divided by the change in your x, right? So the change in my y, I'm going to pick a point, and I'm just going to pick from 2, and I'm going to go up to 4. So I went from 2 up to 4. What was the change in my y? 2, right? Now, I'm going to see what the change in my x was. I went from 0 to 2. So what's the rate of change for A? 1. 1 meter per second, right? Okay. Could I have chosen these 2 points? What's the change if I went from here up to here? From 2 to 6 is a change of what? 4. And from 2 to 4 is a change of 4. So here's the cool part. It doesn't matter what 2 points you choose. Okay? Got that? So you're just finding your points and choosing them from there. So what would the rate of change be for segment C? I kind of gave you a big hint earlier. What's the rate of change for C? At 12 seconds, I'm at 24. 14, I'm at 24. 15, I'm at 24. My rate of change is not changing. So the rate of change for a horizontal line, when its speed is 0. Your speed isn't changing, right? It's kind of like having a table that looks like this. If x is time and y is this, at 12 seconds, I was going 24. At 14 seconds, I was going 24. At 16 seconds, I was going 24. What's the rate of change? 0, right? So do you see what that looks like as a table? Okay, let's save the distance one on the bottom. Go to the elephant run. So the elephant run So let's kind of analyze this. Let's look at segment A, segment B, and segment C. 2 things I need from you. Tell me what's happening in each segment and give me the rate of change for each segment. So, I don't know, let's say the zoo decides to have an elephant race, okay? And they have the timer in their hand, and the zookeeper is going to say, go! And as soon as he hits go, what happens for that first second? Nothing. Because elephants weigh literally a ton. And they could say, do I really want to do this? And go start running? But they got food at the end, so maybe I'll run. Or maybe it just takes an elephant that long to get up and get moving, right? So what is the rate of change during the first second of the race? Nothing. 0. Their speed, okay, is not changing. So finally, after 1 second into this race, this elephant decides, all right, I'll do this. If there's some treat at the end, I'll run. How long does he run for before he gets tired? He runs from, no, careful, this is being very analytical. He didn't run for the first second. He didn't start running until second 1. And when did he slow down? Second 4. How long did he run for? So he ran for 3 seconds. Okay, that's not a rate of change. That's just me asking you to analyze the graph. So to find a rate of change, I can go from here to here, here to here, here to here. I could go from here all the way up to here, from here. You do whatever you want. Why not just do this? So what is my change in my y? I went from, now be careful, it's not 1. My y is, it's almost like your range, right? Right? So I went from 0 up to 3. So my change in my y is 3. Divide that by your change in your x, which is, I went from 1 to 2, which is 1. So my rate of change for segment B is 3. Okay, be a little careful on this one. So what's happening with a negative type of slope? His speed is starting as time continues. The speed is getting slower. He got all the way up to 9 miles per or meters per second. Then now he's at 7. Then he's at 5, and so on. So pick 2 points. Let's just pick this one. I went from this point to this point, which is I went from 5 to 3, right? This is a difference of 2. So look, guys, I went down 2. Do you understand that? My rate of change was down 2, and it changed 2 for every what? 1 second. So my rate of change was from 5 to 3, which went down 2, and it did that in 1 second. So my rate of change for C is -2. Got it? Okay. Let's do the bunny hop. All right. So take a little bit of practice and see if you can do this one. You don't have to write down what the path is. Just be able to explain it if I were to ask you. So what's happening here? And take a minute to find the rates of changes for each of these graphs, okay? Careful on this one. It's the change in your y divided by the change in your x. So I hope you have a rate of change for B at least of 1/2, right? Not 2. 1/2. It went up 1 second for every 1 meters per second for every 2 seconds. Because it went from 4 to 6. So sometimes these don't always represent 1, right? Okay, so somebody explain the path of what's going on in the life of the day in the life of this bunny First of all, do you guys have crazy amount of bunnies and rabbits in your neighborhood? Okay, so we do too. So this is, I kind of think about when my son was 2, he thought he could hunt them and find them and chase them. Not hunt them, hurt them, but he wanted to chase them, right? And you can never catch them, right? So explain to me, if this was what happens in my front yard, what's happening right here? JC. For 4 seconds, this poor little bunny is just walking around, eating some grass, eating my flowers, enjoying the day. And then at 4 seconds, he sees Alex. And Alex, they eye each other, and then Alex starts chasing him. So what happens? Oh, this is minutes. So Alex starts chasing him, which means that this poor little bunny has to increase his speed. So do you understand that's what happened at B? So how long does this bunny have to run from his tormentor? 6 whole minutes he chases him around. All right? From 4 to 10. All right? And he gets going pretty fast. And then what happens after the 10-minute mark? Either Alex gets tired or the bunny gets tired, because what happens to his speed? It slows back down. Okay? So, does this look like it's about the same slope as this? Is this symmetrical? So if this slope is a positive 1/2, then this is a negative 1/2, because you went down 1 and over 2, right? Okay, think you got it? Okay. That is speed versus time. So now I need you to kind of shift your mind over to distance versus time, or time versus distance, okay? So let's take a look at this. You're walking here, and this has got some numbers on it. So this is the time, and this is the distance. What's happening at A? What's happening at B? And what's happening during C? Be careful, because before B, or a horizontal line on your speed, meant you were moving. You're just moving at the same speed. What does that horizontal line mean here? Let's look at this. Let's say that this is the distance from your home. So let's say you're at home right here. Because we're going to say meter or miles and minutes, meters, miles, whatever. If we're getting in the car, 1 minute into our trip, we are 2 miles or meters. Doesn't really make sense after a minute, does it? Because, well, I guess technically, if you're walking, but. So you get and you drive somewhere. We're going to say we're driving. How long does it take you to get to where you're going, to your destination? How long before you get somewhere? 7 minutes. At 7 minutes, how far are you from home? 14 miles. At 8 minutes, how far are you from home? 14 miles. At 9, 10, at 11 minutes, how far are you? So what's happening in a horizontal line when distance is your y-axis? Nothing. You're not moving. You are standing still as a statue. Your distance is not changing. So this could mean, how many minutes are you somewhere? So it's from minute 7 to 11. So for 4 minutes, maybe you forgot something at your friend's house and your parents had to drive you there. You got it. And then what happens after that? And I know what you're going to say. You can't have negative distance. But I'm asking for your rate of change. So you have to put a negative for this line. So what would the rate of change be here? On the way there, you went from 10 to 12, which is up 2 for every 1 minute. So the rate of change for A is 2. What's the rate of change for B? 0. That didn't change. It's still 0. And the rate of change for C is you went down 2, or meaning you got closer to your home for every minute that went by, so negative 2. Okay, do you understand time versus distance? Okay? Okay, so